Start.
So good afternoon, everyone. My name is Ayush Bansal. I am from EC Regular. So today I'm going to present on the topic energy sources. So starting off with the introduction, this presentation will cover various renewable energy sources, including biomass, wind, nuclear, solar, wave, tidal, and hydrogen energy. Each section explores its definition, processes, benefits, and challenges. So starting off with biomass, biomass refers to the organic material derived from plants and animals. Common sources include food, agricultural residue, and waste. Biomass can be used directly as fuel or converted into biofuels or biogas. The conversion process.
Your slides are
Biomass can be converted through processes like combustion, anaerobic digestion, and fermentation.
your slides are not
Combustion
changing.
produces heat for electricity, while anaerobic digestion produces biogas and fermentation produces bioethanol. The main
Slides are
advantages of
not visible.
biogas.
Ayush, only
Yes, sir.
starting slide is visible.
Can you repeat, sir?
Only first slide is visible.
1 second, sir.
Now it changes. Okay, start.
Should I start from the beginning?
Uh,
So, good morning and good afternoon, everyone. Today, my name is Ayush Bansal. I'm from PC Regular. So, today I'm going to present on the topic energy sources, which explores biomass, wind, solar, and more. So, starting off with the introduction, the presentation covers variable renewable energy sources, including biomass, wind, solar, nuclear, wave, tidal, and hydrogen energy. Each section explores its definition, processes, benefits, and challenges. Starting off with biomass energy, biomass refers to the organic material derived from plants and animals. Common sources include wood, agriculture residue, and waste. Biomass can be used directly as fuel or converted into biofuel and biogas. The conversion process. Biomass can be converted through processes like combustion, anaerobic digestion, and fermentation. Combustion produces heat for electricity, while anaerobic digestion produces biogas and fermentation produces bioethanol. The main advantages of biomass are renewable resources. It is derived from organic matter which can be replenished naturally. Waste reduction utilizes agriculture, industrial, and household waste, reducing the landfill burden. Carbon neutral potential. To and managed sustainably, the carbon releasing during combustion is offset by the carbon absorbed during the plant growth. Energy security. Locally sourced biomass reduces dependence on imported fossil fuels. Versatility can be converted into various forms of energy, such as biofuel, biogas, and electricity. The major challenges of biomass are air pollution. Combustion of biomass releases particulates and gases, impacting air quality. Land use competition. Large-scale biomass production may compete with food crops for land and water resources. Deforestation risk. Unsustainable harvesting can lead to deforestation and habitat loss. Inefficiency. Biomass and has lower energy density compared to fossil fuel, requiring more material for the same energy output. High initial cost. Setting up processing plants and supply chains can be expensive. Now, coming to wind energy, how wind energy is produced and how wind turbines work. Wind turbines convert kinetic energy from wind into mechanical energy, which is transformed into electricity using generators. Key components include rotor blades, a turbine tower, and electrical system. Environmental impacts. So the major environmental impacts are on wildlife, uh, which are birds and bats mortality rate. Rotating blades can pose a big risk to birds and bats, leading to fatalities, especially in places of migratory paths. Habitat disruption. Installation and maintenance of wind farms can disrupt local ecosystems and wildlife habitats. Noise pollution. The mechanical and aerodynamic noise from turbines may disturb nearby communities and wildlife. Visual impact. Wind turbines can alter scenic landscapes, affecting tourism and local aesthetics. Shadow flickers. Rotating blades cast moving shadows that can be a nuisance for people living nearby. the global wind energy capacity. So we are going to talk on the total capacity which wind energy can produce. The total capacity which might be produced is 1051 gigahertz by the end of 2023. The growth trends, this involves a record of 120 gigahertz added into 2023, which is the increase of 40% from 2022. The top contributors in wind energy are China, which leads over 400 gigawatts installed capacity. Now coming on to solar energy. Solar energy, photovoltaic versus thermal systems. In this system, photovoltaic systems convert sunlight directly into electricity using solar cells, while a thermal system harnesses solar energy to heat fluids for resident, residential, commercial, and industrial applications. Both technologies have advantages depending on energy needs. Solar energy storage solutions. One of the major issues for solar energy is the storage solution. We will discuss this in the further slide. So, the storage solutions are battery storage, efficient but costly and short lifespan. Thermal storage uses heat, example molten salt, which is space intensive but cost efficient. Pumped hydro stores energy by moving water, high capacity but location dependent. Hydrogen storage, long-term storage via electrolysis, costly and safety concerns. Supercapacitors and flywheels, quick energy burst, expensive and limited capacity. So these are few of the challenges which are faced for solar energy storage. Now coming on to nuclear energy. So principles of nuclear fusion. Nuclear fission is when a heavy atom like uranium-235 is hit by a neutron and splits into two smaller atoms. This splitting releases a lot of energy along with more neutrons and radiation. The new neutrons can hit other atoms, causing more fission in a chain reaction. This process releases a huge amount of energy, which is called nuclear power plant, which is used in nuclear power plants to make electricity and in atomic bombs for explosions. So there's a very old myth or disagreement that nuclear energy is very harmful to health and it is very dangerous and deadly. But there are different kinds of safety measures which are being taken for the nuclear reactors so that they can produce energy safely. So the safety measures and technology. Nuclear plants utilize advanced technologies such as containment structures, redundant systems, and continuous monitoring to ensure safety. Regular inspection and adherence to the strict regulatory standards are critical. Nuclear waste management. Nuclear waste management is the process of safely handling and disposing of waste produced by nuclear power plants and other nuclear activities. This waste is radioactive and can be harmful, so it needs to be stored securely. There are different methods, such as storing it in deep underground facilities, sealing it in a secure containers, or recycling some types for reuse. The goal is to protect people and the environment from radiation for a long time, as some nuclear waste stays dangerously for thousands of years. Now coming on to hydrogen energy. Hydrogen energy is a form of clean energy produced by converting hydrogen into electricity or heat. It is obtained from various sources, including water, natural gas, and biomass. When used, it produces only water vapor as a byproduct, making it environmentally friendly energy source. There are different types of production methods for hydrogen are hydrogen production method, steam methane reforming, electrolysis, coal gasification, biomass gasification, electrochemical water splitting, biological methods. Some of the applications of hydrogen energy in energy storage. Hydrogen serves as a versatile energy carrier, stored and useful in fuel cells to generate electricity. It is particularly valuable for balancing supply and demand in renewable energy systems. Future of hydrogen economy. The future of hydrogen economy looks promising as it can help in reducing carbon emissions and promoting clean energy. Hydrogen can be used in transportation, industry, and power generation. Advantages in technology are making hydrogen power production more efficient and affordably, especially using renewable energy sources like solar and wind. Government and companies worldwide are investing in hydrogen infrastructure, such as fueling stations and storage systems. If challenges like high production costs and safety concerns are addressed, hydrogen could be a key player in achieving a sustainable, low carbon future. So, the conclusion of this PPT is renewable energy sources such as biomass, wind, solar, nuclear, and hydrogen present essential paths for sustainable energy. Each technology has distinct benefits and challenges that must be considered for a balanced energy future. Thank you.